So we begin with a short presentation. Today webinar of StreamEye Studio is for codec developers and video equipment manufacturers. My name is Fedor. I'm Elecard technical expert. Please, during our webinar, feel free to ask your technical or business questions in our chat. I will be able to answer all of your questions at the end of our webinar, or we will answer it in full later over email when we'll get comments from our technical engineer. Quickly about today's webinar program. We will review essential information about StreamEye Studio, its graphical interface, features, supported formats, and general information about StreamEye. Then we will move to StreamEye live demonstration, where we will be able to review in detail StreamEye functionality and typical different workflow related to codec development mostly, and how to check your video streams used during codec development. Then we will be able to check a couple of essential StreamEye features, which is, according to our experience, used rarely. That is how to use master-slave mode in StreamEye, and a couple of other features, how to compare different streams to each other, calculate different quality metrics with StreamEye. I would like to also start with explanation of the total package called StreamEye Studio. StreamEye application is a part of package called StreamEye Studio, which consists of several different applications. One of application is StreamEye, which also supports automated mode called StreamEye Console. It allows to use StreamEye from console, and the essential purpose is to analyze lots of media files at the same time in automated mode. There is another couple of important applications included in StreamEye Studio package. One of the application is Stream Analyzer, that is Transport Stream Analyzer. If you already have experience with StreamEye application, then you know that StreamEye is focused on video elementary stream level, on compressed bit stream analysis, and not on media container level. But typically, we would like normally to understand what's going on both levels, on media container level and on video elementary level. So media container level, either that is transport stream or MP4. So both of that media containers is possible to analyze and check structure with StreamEye Studio tool called Stream Analyzer. Stream Analyzer tool as well supports console mode for automation analysis for large media assets. There is another application included in StreamEye Studio focused on quality comparison of different media streams. That application called Elecard Quality Estimator, and it supports as well console mode. Operating system that is supported by StreamEye Studio, all of applications included in StreamEye Studio, and by StreamEye application as well. That is Windows operating system, and that is Mac. So a bit of essential features of StreamEye. So the first questions that all of StreamEye users are interested in is which codecs do you support? In StreamEye, we support traditional codec MPEG-2. We support AVC or H.264. Around 3 to 5 years ago, we started to support HEVC video codec, and we support it in full, as well as VP9. And end of January next year, end of January 2018, we are going to support AV1 video codec. Why the schedule is like this is because end of this year, AV1 bitstream is going to be fixed, and there will be no changes in compression algorithm used for AV1 video codecs. So we will be able to include to finalize development of AV1 AV1 format in StreamEye in our StreamEye application. So essential features of StreamEye, of course, is video bitstream analysis down to macro block level, calculation of different quality metrics when we compare compressed video file and coded video file with raw reference stream. So those quality metrics are very traditional and most popular per metric, as well as other metrics that you see on this slide. There is an interesting feature which we will review in detail related to automatic synchronization or simultaneous usage of two running StreamEye instances to operate with two different media files synchronously. Of course, there is also 4K video support. There is automated analysis to analyze large media files assets in automated mode, and there is a standard compliance verification to check if during decoding stage our decoder found any issues with a video bitstream. So let's move to StreamEye demo. I'll share my screen. I'll share my screen where I have StreamEye running. Okay, I'm sharing my screen right now. If you have any troubles with video picture, please let us know in our live chat, and there is a technical support team behind me. They will be able to let me know, and we'll try to do something about it. Also, as I mentioned, please feel free to write down your questions during presentation of StreamEye, and we will be able to answer your question at the end of this live presentation. So currently you are looking at StreamEye latest release version 4.4. You might be using StreamEye already, and your version might be lower than 4.4. It could be 4.0 or even 3 point something. So let us know, and we will see how we can provide you StreamEye 4.4 for your evaluation to see what's the differences. So currently I'm running on my laptop. I have Windows 10 operating system. So you are looking at StreamEye 4.4 running on Windows operating system. I have, you may recognize it already by this picture. So I'm running, I'm using Bugs Bunny video stream as a sample. So let me begin with a review of StreamEye functionality and main windows. In the beginning, I would like to mention that StreamEye has lots of features. Currently, we are looking at 1, 2, 3, 4, 5, 6, 7 screens, and each of screen has 7 windows, and each of window has several tabs. Like one of the window has 7 tabs, another has 4 tabs, another 4 tabs, and so on. So StreamEye really helps you to understand parameters of your compressed video stream in a lot of details, to go very deep inside compressed stream and see all the details that were implemented by video encoder. So we'll begin from the basics. On the top you see the bar chart. In the bar chart, StreamEye shows all the frames that the video stream consists of. By the height of the bars we show size of the frame, and by the color we show frame types. So those two parameters of frames are the most essential parameters. So we would like to know what's its current frame type and what's its size. So by red color, when I'm moving my mouse cursor over frames, you see some help window which shows me a bit more details about frame where I'm navigated to. So I see that my current frame type is iframe, and I see the size. I see the size of the frame, and I see bit allocation. So that's the bit rate on the current frame. So 977 kilobit per second is the bit rate of the video stream at the current level. So I can navigate. So by red color we show iframes, and then of course iframes have our biggest size, so They are represented by largest bars. And then blue is P frames. And in the middle, there is green frames, which have smallest size. So they are B frames. What else we show on top of the bar chart? At the top left of the bar chart, you see bit allocation and quantizer, red and blue line. So on top of the bar chart, we show this information. We show red line, so we can quickly understand how bitrate of the stream is changing through the frames. If you keep tracking the red line, that you see that it's changing. So our stream is encoded with variable bitrate. And on the top there is a blue line which show current quantizer for each frame. So we see that quantizers, they are mostly the same. What's the essential purpose of the bar chart? Of course, it allows you to navigate to the frame if any frame is interesting for you. For example, I'm really interested to understand why my P frame, which has display order 5812, why it's so large, because the bar is really high, and it means that P frame has a really large size, and I would like to understand why, because normally largest frames, they are I frames, and P frames, they as we see from the bar chart, P frames, they are typically smaller than I frames. So I can quickly navigate using the bar chart. I can quickly navigate to the frame which I'm interested in for further investigation and analysis. So again, bar chart is the tool of StreamEye, is the window of StreamEye, which helps you quickly to go through all the frames and visually pick a frame that catch your attention, and then quickly navigate to that frame and perform some further analysis. So we'll come back to this P frame later to understand why it has why it's so unusual in comparing with another P frames. But now I will continue with another window. So besides the bar chart, we have thumbnails, which allows to navigate through thumbnails. So we have small previews of each frame in this thumbnails window, and if our stream is really large, and we can visually find the scene that we are interested in. So back to the bar chart and back to our P frame. In the center, so I can change all the window size. So my screen is not that large, so it's more convenient for me if I make some windows smaller. So in the center we see our frame, so that I'm currently navigated to. That's a P frame that we want to investigate why it's really so large. So I'm looking at the frame, and this is my mouse cursor. You see that when I'm moving my mouse cursor over the picture, first of all, there is some square blocks. So that square blocks is the current CTU block, and on top of the main frame, I can put information about blocks that frame consists of. So what is that information? So first of all, I can put information about block types. So blocks, this is HEVC video, by the way, and in HEVC video, blocks can be predicted or bidirectional or skipped or inter-predicted blocks, and we show all of them by colors as well. So in comparing, if we switch to the B frame, we see that some of the blocks on top of our frame has a transparent color, which means that they are skipped blocks, totally predicted, 100% predicted from reference frames, and so they're basically a copy. And then there is some blocks which are marked with blue color, so they are predicted plus some information on top of the motion vector to compress the difference between current block and block which current block is predicted from. And then there is some blocks which are marked by red color, by orange color. They are intra-predicted blocks, means that those blocks has no references to any other blocks on other frames, and basically those blocks they are compressed as an image, as a JPEG image. So and this is what gives us actually size of the frame. So as more intra-predicted blocks we have, as more orange colored blocks we see on top of the frame, as more size, as a bigger size our frame has. And currently I'm looking at B frame, which is represented by black bar on the bar chart, and you see that the size relatively small in comparing with other frames. That's because most of the blocks on the current frame, they are either skipped or predicted by blue color, and we have only one small object, probably 7% of the frame, which consists of blocks which are intra-predicted. So if we quickly go back to the P frame, which has larger size, we see that most of the blocks, almost 100% of the blocks of this P frame, they are intra-predicted. And intra-predicted means that they are basically encoded as a picture and have no reference to another frames. And that's why our P frame has such a large size. So means that encoder actually didn't do a great job on this frame, or accidentally it marked this frame as a P frame, but actually it looked very much like I frame. We still have some predicted blocks on this frame. If we go deeper into the details, there is also possibility to add information on top of the, okay, so let me just avoid this, and I'm able to add information on top of my cursor, like again types of the blocks and motion vectors, for example. So I see that this blue block that I'm currently looking at, it has a P type, it's predicted block, and it has a motion vector. So it has motion vector, and that's why when I'm selecting this block, if you quickly look at the bar chart again, you will see red circles with numbers inside, 0 and 1. So by red circles on the bar chart, we show reference frames for the current frame. And when I'm navigating among the blocks, you see that some circles become highlighted. Means that I select block. Currently, I'm looking at the block which is predicted from the highlighted frame. So I can by click I can fix my block, and I can go to the highlighted frame. This is the frame which is highlighted, and this is the frame where my current block is predicted from. On the right side, you already mentioned, I'm sure, that we have a block presenter window where we show current block, but in full, so that's zoomed. Because imagine currently I'm looking at picture which has 640 by 360 resolution. Imagine if you are looking at 4K pictures, so either you need a really large screen or even several monitors, or it's easier and more convenient to look at the zoomed image of the block that you work with. And so let me quickly switch to the B frame again. Okay, so I can select some block which has interesting structure. So that CTU block consists of coding units. So that's coding 3 block unit according to HEVC specification, and it consists of coding unit blocks. And when I move my mouse cursor to block presenter, I can get essential information about each coding unit block that I'm currently looking at, including its location, type, dimensions, size. Size consists of prediction and transform data, as well as information related to transform part of the block and prediction part of the block. This is how we can work with macro blocks. On top of in the block presenter, there is also possibility to add information that we like to see about the blocks. So I actually edit everything: motion vectors, types, and the background picture. I can also add text information but currently here is, yeah, I can add text information. So I can add prediction type for each block, I can add size for each block, and I can add a quantizer for each block. So when I'm looking at the block by small numbers on the top left corner of the block, I see these three informations about current block: prediction, sizes, and quantizers, which is helpful when we want to understand why our encoder decided to choose this type of prediction, and what finally the size of our block and which quantizer our encoder decided to apply to the current block. And then we can go back to our source code and understand actually why encoder did that decision. So that's how to work with macro blocks. Let's quickly review another interesting features of StreamEye. So in the center bottom, you're looking at the message window, and we see here 5 lines. We see 5 messages. So those messages are potential errors or warnings which were found by decoder during StreamEye decoder during decoding of the stream, together with text message and explanation of the error, including reference to the HEVC specification item. You see the address or the offset in a stream where this error is located. When we click on the error on the left side window, left bottom corner, there is a window called Stream Viewer, where we see all the information that stream consists of. Headers. So when we click on the potential error in the message window, Stream Viewer automatically navigates to that header, so we can dig down and right. So you see that I'm clicking on different messages, and Stream Viewer automatically navigates to that. So I can open that and dig down and see what's wrong in particular. What's wrong in particular with my stream. So I'm able to see all the details inside my stream, until super details. Yeah. So that's a Stream Viewer and a message window which are connected to each other. So right after opening a media file, you can quickly look at the message window and see if video stream has any errors, potential errors or warnings detected by decoder, and you can see the explanation and text information. What are those errors? Another interesting functionality of StreamEye is buffer analyzer. So there might be situation when our encoder decided to not our encoder, I'm sorry. There might be a situation when our video file is going to be played on a set-top box, for example, which has quite limited buffer to keep all the frames. What is that buffer? So what we need to actually keep in that buffer. So remember, we were talking that current frame may have some blocks which are predicted from the previous frames. So means that during the decoding stage of the current frame, we need to save and to keep in the decoder memory all previously decoded frames, some of previously decoded frames, which are reference frames for the current frame, because we need them, because we will use information from those frames to reconstruct blocks on our frame. So that is called decoding picture buffer. And in decoding picture buffer, StreamEye allows you to see which frames are actually located in decoding in the buffer of decoder. So which frames are there for decoder to use them to reconstruct current frame. This is decoded picture buffer. So in order to have pictures in that buffer, we need to have a buffer, and we have that buffer. And this informational window shows how buffer is being used during decoding of the stream. So we can navigate and we can see that the red line is changing. So red line is show us fullness of the buffer. So during decoding of the video picture, we want to avoid two situations. We want to avoid situation which is called buffer overflow, means that imagine it's a live video streaming coming to your set-top box, and buffer of the decoder set-top box is full. So there is no more left space to keep new data, and decoder will actually skip new coming data, and we may experience troubles, lost frames with our video stream. Another situation is buffer underflow, when we decoded everything and we are waiting for the new data. So that's also a bad situation. In this case, we will experience pauses and freezes during playback of current video stream. So this windows helps us to understand what is declared buffer size. It's in the left part of the buffer window. We see that declared buffer size is 3.3 meg, and by graph we basically look at how the buffer is being used. So we can first of all, during development of our decoder, we can see how it's been used, and we can quickly check that there is no buffer overflow or underflow situation. That's probably all about how to work with a single frame. I would like to now focus our presentation on a couple of another interesting features. First of all, how to compare two video streams with each other to understand what's their quality. For example, what's the quality of our compressed stream. So imagine you have an encoder, and that encoder takes a raw input from either SDI or HDMI source and encodes that with some codec, and you would like to understand what's the difference between your compressed stream and your high quality input stream in terms of some quality measurements metrics. So StreamEye allows you to open, I'll do this right now. So we're gonna open some, let's open some video which is encoded with YouTube video codec. So we open video encoded with YouTube video codec. StreamEye shows us that it has one video stream inside encoded with AVC format, Full HD resolution, 50 frames per second. We select this video stream and it's going to be open. Okay. So give it some time. StreamEye is currently processing it. And we go to reference StreamEye menu and we open reference for our media file. So I have a reference for this media file. That's YUV format. So I open it. There is another possibility to check that your reference, because that's reference, so we need to tell StreamEye, we need to inform StreamEye which color space is used in that reference video file. So we have a reference configuration window, which I can, let me make it a bit bigger to see. So yeah, so here I have several color spaces. By default, the first one is selected. So I can just basically change the color space and see how picture looks like. So when the color space is right for this picture, the picture looks perfect. And I click OK. And so when reference is selected, so I can, yeah, there is a play button functionality, so I can actually play my video stream. You need to know that stream in almost all cases cannot be played in real time. That's just because during decoding of each frame, StreamEye has to do a lot of calculations associated with that frame in order to show us how frame was encoded. So when I have my reference stream, now let's look again at the central picture where I have my decoded frame. You see that this window actually consists of several tabs. Currently we are looking at decoded, tab called decoded, and then there is also tab called unfiltered, predicted, residual, and reference. So let me zoom our picture at the current frame. So I'm looking at some group of people in here. So that is compressed stream, and the stage is called decoded. Decoded means that this is what the final picture that we look at after decoding. So this is the picture that we look that we see on the screen when we play our video file. And there is also tab called reference. So this is my reference picture. You see that we have lots of details on reference picture, which we miss a lot on our compressed image. So this is what happened when encoder took our reference, our high quality video stream, and compressed it, skipped some data, skipped some information from all the frames, and finally we received decoded picture. Let's look at the video stream information. We are looking at, again, full HD video stream encoded with high profile. That's AVC video stream encoded with high profile, a full HD, 50 frames per second. I'm looking at stream window right now. And if we scroll down, we are able to see what's the bit allocation. So basically, what's the bit rate of our stream? We see that average bit rate is 5.6 megabit. So that is AVC video stream full HD, 50 frames per second, encoded at 5.6 megabit by YouTube. And so this is how picture looks like. Of course, when we zoom it out, so it looks more or less acceptable and all nice to see. So, but if we zoom in, of course, we see that our reference picture looks much better than our decoded picture. So there are other tabs that you look at called residual, predicted, and unfiltered. So those tabs show us how picture looks like during different decoded stages. So one of the first decoding stages is predicted. So when we took current frame and reconstructed all blocks on the current frame using reference frames, but didn't yet add difference information between current frame and frames that that is reference for the current frame. So I'll switch to the predicted, and you see that the picture looks significantly worse. So again, this is the decoding stage where we reconstructed all the macro blocks on the current picture using prediction information from the previous frames, but didn't yet add difference information between current frame and reference frame. So that information is called residual. So this is residual information that is currently shown in. For easier, we can choose the color space that we would like to look at. For example, on the Y component. And so that's residual information, which is added. I can fix my cursor so it will not be that much annoying. So residual information, that is what added to the predicted frame in order to receive final decoded picture. There is also, well, it's actually not like that. What we will receive, we will receive unfiltered picture. So the difference between unfiltered and decoded is that we apply deblocking filter to the unfiltered picture. Looking at the unfiltered picture, you may notice blocking effect. You clearly see borders of all macro blocks on the picture. So those borders are not looking good for human eyes. So there is a filter which is called deblocking filter. It's analyze pixels on the borders and smooths them out in order to make picture looking better for our eyes. And when we apply deblocking filter to unfiltered picture, we finally have our decoded picture. So this is the difference. So instead of clicking by tabs and understanding the difference this way, we have another function of StreamEye, which is called difference. So this is the button. I click on the button. In interface, it's named F. So I click on the difference button, and you may notice that in the main window I start to have another tab called difference. That's the tab which shows me difference between selected stages of decoding or between selected streams, if I'm using reference stream as I use right now. So we select two frames. Let's select decoded frame, and let's select reference media stream. And I would like to understand what's the difference between decoded and reference using different type of calculation. I would like to start with, for example, temperature, which visually shows me the difference. So, okay, I'll zoom it out and make it colorful. So we are looking at the difference represented as a temperature. So colors are changing from black and then blue and then green and then finally red. So by color here we represent how different are pixels between decoded video picture in compressed video stream and pixels in our raw reference stream. So let's take part of the picture which has a lot of red lines in here. So this is some part of the tree. So if we look at this, and again, so here is our reference and here is our decoded. We see that the pictures are really different from each other, and that's why in a difference tab we see those parts marked with red. I can also switch to the PCNR clip. Let me zoom it out. So PCNR clip shows us PCNR information for each block on the current frame. In case we are most of the times we are interested, of course, to understand what's the average value of PCNR for the whole frame. And for this, we may go back to the bar chart, and on the bar chart we can put another interesting information which is called metrics. So we put metric information of the bar chart, and you see we start to have green line. Green line which shows us PCNR value for each frame. So that's average among all blocks on the frame. So that's average PCNR value for each frame. You see that the green line is calculated actually not for all frames, because I press pause button. And if I press play again, so you see that it's keep calculating, and the picture is changing. So this is the way how we can calculate PCNR value for each frame and see actually the difference, how PCNR value is changing from frame to frame. Besides PCNR calculation, if we go to the settings of the software, of the StreamEye, we can change the metric, the calculated metric. Besides PCNR, we are able to calculate delta, MSAT, MSA, PCNR, and SSM metric. So it's about quality comparison of two video streams, reference and compressed, using StreamEye. One more essential feature that I would like to show before we will move to the questions and answer section. That is how to use two StreamEye simultaneously, two StreamEye instances simultaneously in order to compare two compressed streams to each other. I already have another StreamEye open here. So this is another StreamEye instance. So the stream that I opened in this second StreamEye instance is the same to the first StreamEye, but encoded with codec X264. So This StreamEye window has a video stream encoded with YouTube codec, and this StreamEye window has video stream encoded with X.264 video codec. And I'm looking at the decoded picture as well. So how to use two StreamEye applications simultaneously, and what is the feature actually? What is the benefit? So I also switch to the decoded tab of the current, and there is a button called listener mode. So when I click on this button, my current StreamEye instance goes to the listener mode. Means that it will start to listen commands from another opened StreamEye instance, and it will follow all the same actions that user performs with another StreamEye instance. So I click on this listener mode, and then I move. Okay. So and then I move, and what happened is that you see that when I'm navigating over macro blocks of the one StreamEye instance, my second originally open StreamEye also navigates through the same macro blocks. What's interesting is that even, of course, if I change the frame, so let's say in my another StreamEye, I would like to switch to another B frame. So I click on a B frame. Okay, and I'm switched to the B frame. So when I start to navigate, the first StreamEye instance automatically switch to the same frame as well. How to see it? Let's quickly go to the bar chart. We see that display order of the current frame is 150, and that's a B frame. And in our first StreamEye, the current frame, which is black color, is also 150, and that's also B frame. So by looking at two StreamEyes at the same time, we can go through macro blocks and see what's the difference between two compressed streams. Not just difference in terms of quality, but also difference, first of all, difference in terms of macro block parameters and structure of the frame and structure of the macro block. So we can easily understand and see the difference in compression algorithm of macro blocks. So during development of our encoder, we changed some parameters, and encoder decided to compress this stream in a different way. So we use this mode to understand what's the difference in the way how encoder decided to compress our stream with different parameters. Basically, that's all. I explained all essential features of StreamEye. I would like now to switch back to our webinar room. And please give me your questions. Please write down your questions in our chat, and me or our technical engineers will be able to answer all of your questions. While you are writing your questions, let me quickly go back to the presentation which we started with originally. And I would like okay, so we had a first question. Source resolution is too high. Can see some info on lower resolution monitors. Well, yes, that's true. That's true, but that's why we can zoom. That's why there is a zoom. That's why there is zoom functionality in our StreamEye application, so we can zoom in. Basically, most of the windows we can zoom them in and see all the details, all the pixels, even on monitors with lower resolution. So my monitor has Full HD resolution, but I'm able to work even with 4K videos in StreamEye. I just use zoom button. That's not that much convenient, of course. If you work with StreamEye and 4K video, the typical setup for StreamEye consists of 2 double 4K monitors in order to use streams comparison functionality of StreamEye, either using 2 StreamEye instances running simultaneously, as I mentioned, or just using compressed video stream and reference video file. So we can move StreamEye windows to different monitors and basically make our workflow easier. So this is the way how we can use StreamEye with high resolution streams. Just use zoom button. So while you are writing another questions, a couple of StreamEye licensing features. So already mentioned that StreamEye is available for Windows and Mac. How to try? We have free trial demo, which will last 30 days on your computer. It has limitations. You are allowed it only to operate with 42 frames, or first 42 frames of video stream that you open. You are able to operate only with that amount of frames. And we have a free full-featured demo version, which will last 7 days, and it has absolutely no limitations. It's full-featured version, but it will last only 7 days on your computer. StreamEye, speaking about StreamEye licensing, it's available as a standalone application. We call it single seat license, and as well it's available as a floating license. What floating license is that, imagine you have a group of developers, say 10 developers, and you know that 3 of them will be using StreamEye at the same time. Any 3 of your developers may use StreamEye at the same time. So this is floating license option. So this option for such cases. It allows to install unlimited numbers of StreamEye copies on any amount of computers that you want, but only limited amount of simultaneously running StreamEye instances is allowed. So say your floating license will be limited to 3 instances, or we call it 3 connections, and so only 3 StreamEye instances can run at the same time. As mentioned, StreamEye as well as is a part of StreamEye Studio, and we look forward to see you on our next webinars, where we will review another applications included in StreamEye Studio package. I already mentioned that we have Transport Stream Analyzer, which designed to work with transport stream and MP4 media containers, and video quality estimator, which is more than StreamEye, focused on quality comparison of several streams with each other. We got another question. Do you plan to release StreamEye for Linux? Well, it's an interesting question. We receive such requests from time to time, and the current stage of this development is called collecting requests. So please let us know if you would like to have StreamEye on Linux, and once amounts of requests, once we will collect enough requests, then we will start this development. But we do not have any immediate plans on releasing StreamEye for Linux. Another question from Olga. Often we need to determine if the source TS had the corruption. If bad, can we generate output reports? Well, analyzing of transport streams is not the functionality of StreamEye application, which we are currently reviewing, because StreamEye is dedicated to video bit stream analysis or video elementary stream. analysis. There is another application which is a part of StreamEye Studio called Stream Analyzer, and the job to be effectively done by Stream Analyzer is to analyze transport stream level. And that application allows to analyze transport stream level using TR-101-290 protocol. That's a large document with explanation of different possible errors which may happen on transport stream level during delivery or during delivery of a video stream, commonly over IP networks. And all those errors, they are combined in 3 priorities. And Stream Analyzer allows to analyze all of that priorities, all of that errors from Tier 101 standard, and of course provide final analysis report. Some more words to previous question with some screenshots. Yes, of course. So let me quickly back to our live demo. I'll share my desktop again. And so we will be able to look at how to work with 4K video streams. Let me just simply find 4K video stream and open it, and we'll see how it works. I have some basketball drive video stream. Let me see if it's 4K. No, that's full HD video stream, so I'll find another. I definitely have some 4K video stream. So yeah, I have some 4K TS file. Okay, that's HEVC 4K video stream, 29.97. That's not going to be fast on my laptop, but anyway, let's see how. So here I'm looking at 4K video stream. So it's a 4K picture, 4K video HEVC encoded with main profile, 59.94 frames per second, with declared bitrate 20 meg, and actual average bitrate is 18 meg. So this is 4K stream, and how to operate with such streams when you have low resolution monitor is just a zoom function. As I mentioned, we have a zoom function in here, so I can let me just avoid some information about it. So I can zoom in. That's the first way. I can zoom in the main frame that I'm looking at, and secondly, in the block presenter, which is on the right side of StreamEye. In the block presenter, we always show our currently selected block in 100% resolution. There is also possibility to change. So currently it's auto. So auto means that when I'm changing my window size, so the block will be zoomed accordingly. So this is the way how you can basically work with 4K stream, right, on a low resolution monitors. So this is the way. So I'll go back to sharing our presentation. Please, if anything not clear regarding how to work with high resolution video streams, please let me know again, and maybe ask me a bit more specific, and I'll be able to answer in full. So on the previous slide, we already reviewed what's their StreamEye licensing policy and information about StreamEye Studio package and other applications that we will inside StreamEye Studio package that we will review later during our next webinars. Probably the last slide is about a bit more about who is StreamEye clients. We have lots of StreamEye users all over the world. Most of them sit in their North America. Because this webinar is dedicated to Asia Pacific time zone. So here we listed a couple of six our biggest customers in Asia Pacific. Those customers, they are R&D centers. I see only licensing info. Probably just wait, Vadim, for a second, and because I'm looking at StreamEye clients slide, probably it will take just a while and it will automatically switch to StreamEye clients slide. So in Asia Pacific, StreamEye users are research and development centers of video chip, mostly manufacturers, and digital TV, digital displays manufacturers, and broadcasting equipment manufacturers, companies like Huawei, located in China, Intel, located in China, Samsung, located in Korea, Sony and TV Tokyo, companies located in Japan, and HiSilicon company, which is a part of Huawei, dedicated for chip manufacturing. HiSilicon is located in China again. So those are our largest users of StreamEye. Probably, if there is no more questions, I hope, Vadim, that you finally able to see last slide of our presentation with StreamEye clients. We will send you email and we'll explain you more about how to work with StreamEye high-resolution streams. And of course, to all of you, if you are interested in evaluate StreamEye yourself, please let us know. As mentioned, we have full-featured 7 days demo, so you'll have a week-long StreamEye without any limitations. So you can analyze 4K streams, large streams, small streams, all of the codecs, except of AV1, which we are going to release at the end of January next year. And please subscribe to our next webinars, where we will review applications from another applications from StreamEye Studio package. They are transport and MP4 media container analyzed, called Stream Analyzer, and video quality estimator applications focused on comparison of several video streams to understand quality of streams. Thank you very much. Looking forward to see you on Elecard webinars again.